Welcome to Unit 4. In this video, we will be going over the basic elements of apportionment. If you haven't heard of it, let me introduce you to the small country called Parador, and it's in Central America. Parador has 6 states, and you can see them listed here along with the population of each state. The population for the entire country of Parador is 12.5 million people, and they have 250 seats in their Congress. How do you think these 250 seats should be divvied up to these 5 states? You might initially think 250 seats, 5 states, divide them up equally. That would give each state 50 seats in Congress. Equal, right? Not really. In fact, if we did this, we would have one really unhappy state. Bahia has over 6.9, almost 7 million people. They definitely deserve to have more representation in Congress than any of the other states. This is the whole idea of apportionment. How do we take seats of Congress and divvy them up to each state in a way that's fair? It's definitely going to take a little more work than just dividing the seats by the number of states. Let's break this problem up into 2 questions. The first question is, how many people should each seat represent? Parador has a population of 12,500,000 people. They also have 250 seats in Congress. Just looking at these 2 numbers, we can figure out how many people each congressperson should represent. By taking our population and dividing it by the number of seats, we find that each congressperson should represent 50,000 people. This is what we call the standard divisor. Now for our second question. Now that we know that each person in Congress should represent 50,000 individuals, how many seats should each state have in Congress? Well, let's look at each state individually. Azucar has 1,646,000 people. How many groups of 50,000 is that? If we take that state's population and divide it by 50,000, we find that they should hold 32.92 seats in Congress. Bahia has a population of 6,936,000. Dividing that by 50,000 tells us that that state should have 138.72 seats in Congress. Continuing in this way, we can find how many seats in Congress each state should have. Adding up all of these seats, we have our grand total of 250 seats exactly. Seems perfectly fair, right? Just one problem. How do you have 32.92 seats? Those are people. You can't have partial people. You can't have partial seats in Congress. We have to have whole people or whole seats in Congress. The apportionment always has to be whole numbers. So what do? Round? Suppose we do our conventional rounding, that is, round to the nearest integer. That means that our first state would have 33 seats. Next, we would have 139. 3.08 would round down to 3. 41.82 would round up to 42, 13.7 rounds up to 14, and 19.76 would round up to 20. That's fine, and I'm sure most people would be happy, except when you add up these numbers, they add up to 251. Now we don't have 251 seats, we only have 250. So conventional rounding is not going to work on a regular basis. What if we instead round everybody down? That's fair, right? If we round every standard quota down to the nearest whole number, this is how many seats each state should get. This is called giving every state their lower quota. That might seem fair just to round everybody down, but now we've only divvied up 246 seats. What are we going to do with the leftover 4? In a similar fashion, we could instead round everybody up, but I think you might already know what's going to happen. Rounding every state up, we are giving them what's called their upper quota. If each state receives their upper quota, we've in effect given away more than we had to offer in the first place. So now we know that conventional rounding is not going to work. Neither is rounding everybody up or down. Sometimes these might work, but they're definitely not going to be reliable methods for apportionment. This is where we need the likes of Alexander Hamilton and his buddies to bring in some apportionment methods that will divvy up the seats in a way that they thought was fair.